Welcome everyone. In this video, we're going to look at the Maxwell-Boltzmann distribution, what it shows, and the key features you need to be aware of when you're asked to sketch the distribution. Please like and subscribe if you're interested in more chemistry videos. Also, post in the comments if you have any questions about this topic or suggestions for future videos. Let's get started. The Maxwell-Boltzmann distribution shows how the energies of particles are distributed in a sample. Sketches of Maxwell-Boltzmann distributions can be used to explain why reaction rate increases when temperature is increased or in the presence of a catalyst. First of all, let's think about what a distribution is. In statistics, a distribution is a function that describes all the possible values that a variable can take and how often they are expected to occur. It essentially shows the spread and pattern of data. For example, if a six-sided dice is thrown many times, you would expect each number to be rolled an equal number of times. We could test this and plot the results on a graph. The first time the dice is thrown, the number 4 is rolled. If you roll the dice a few more times, the distribution shown on the right may be observed. Assuming that the dice is fair, when it is rolled many times, the frequency of each number thrown starts to even out. There are other distributions, such as the normal distribution and Poisson distribution. You may come across these in maths or statistics courses. We will return now to the Maxwell-Boltzmann distribution that is used by chemists to explain changes in reaction rate. The Maxwell-Boltzmann distribution shows how the energies of particles are distributed in a sample. Energy is plotted on the x-axis, number of particles with a given energy is plotted on the y-axis. Let's build up the distribution. The block represents that one particle has one specific energy. The energies of a few more particles have now been added. Eventually, we begin to see a pattern. Each red block represents one particle here, so the total number of red blocks is the total number of particles. The number of particles, or molecules, is discrete data, so the number of particles can only be a positive whole number integer value. It is not sensible to show the Maxwell-Boltzmann distribution as a bar chart or histogram. The number of particles can be treated as continuous data because there are so many particles, billions upon billions. You should take some time to practice sketching this distribution. It is often required in exams. You should also memorize the titles for each axis. Next, we're going to look at some of the key features of this distribution. The area under the curve, highlighted yellow here, is equal to the total number of particles. 0 particles have 0 energy. The line must go through the origin. It is not possible to state with certainty what the maximum energy of a particle is, but as energy increases, there are fewer and fewer particles with increasing energy. This part of the distribution must be shown as sloping downwards. It must never appear horizontal or point upwards, and it must never cross the x-axis. Most particles have the most common energy, labelled C here. Because the distribution is not symmetrical, the average energy, labelled x bar, lies slightly to the right of the most common energy. Thanks for watching. I hope you found the video useful. Don't forget you can always email info@flipchem.com for a free user account on the main website. Take care and good luck with your studies.